Okay. Good morning, all my dear students. Still only 75 students are present. So I think now only the Python lecture was left, maybe. So again,
Yes, sir.
1 or 2 minutes, I give time to you to join the remaining students. So please, only 75 strength is present out of 138. Okay. Uh, if any neighbor students are there, please you insist to them to join the lectures. Yes, fine. Anyhow, I made enable to all of you for waiting room. So in their own time, they have to join, no problem. Okay. Dear all students, so last class and last to last class. So I may think my speed is on an average. So एवरी क्लास में आप सभी लोग जांच करा दीजिए अगर कुछ एडजस्टमेंट है कुछ करेक्शन है तो भी बता दिए सो एज पर लास्ट टू लास्ट lecture I got some suggestion from the students like you so as per that I reduce the speed so maybe I am on an average even still dear student don't hesitate any of your suggestions or your comments are there, please you hand over to me. You have to send me a text or a message or a WhatsApp message or a mail or whatever you have to communicate and give me suggestion. Okay. So because I have only one problem that is I don't know Marathi, so I'll try to convince in Hindi and English to you. So in that situation also, if any want to changes, you need changes, you have to tell me. So now onwards, I will move only this speed. If this is also you feel like it's a speed, again you have to tell me. Again I will reduce to my speed. So only my intention, you have to understand each and every topic, each and every line of the subject. Okay. So this is from my side words. Cooperate me, you and me together, we have to success in this subject. So it is my intention. Okay. So yes, now it's time to start. So before that, uh, as usual, I have to say good morning to all. Very, very good morning. Have a nice day. So uh, just I will check. Dear students, am I audible and my screen is visible to everyone?
Yes, sir.
Yes, sir. Audible and visible.
Okay, okay, fine, fine, thank you. So dear all students, already we are continued. Uh, actually today is the practical session, right? So, but I'm almost practical. We have to completed 6 programs, means 50%. So again, we will complete this fifth unit of the theory part. After that, again we will go for seventh and eighth program of lab session. So again today we will go with a lecture that is the units theory part. So already I am started unit number 5, that is interrupts. Introductions we have to cover, definition of interrupts we have to cover, and parts of types of interrupts we have to cover. That that is mainly uh, types of interrupts with mainly two types है. That is hardware interrupts and software interrupts. Again hardware interrupts में फिर दो सब कैटेगरी है that is maskable interrupt and non maskable interrupt. एंड सॉफ्टवेयर इंटरप्ट्स के अंदर 256 इंटरप्ट्स है. दोज 256 इंटरप्ट्स मतलब 0 to 255, 0 to 255 interrupts. It means totally 256 interrupts are comes under software interrupts. That one we will study in later. Actually, for your syllabus, as I said earlier, hardware interrupts are there for your syllabus. That is in the hardware. इसमें अभी दो सब कैटेगरी क्या है, मास्केबल इंटरप्ट है और नॉन मास्केबल इंटरप्ट. So these two maskable and non-maskable we studied in the last lecture. That is non-maskable interrupts. Hardware interrupts के अंदर non-maskable interrupts आ जाएगी. Our interrupts. Normally we have to say interrupts or maskable interrupts. इसमें आ जाएगी. These things we are carried already. And today, and one more thing, that is interrupt service routine. Interrupt or and interrupt service routine also we studied in the last class. These interrupt service routine is where take a main role in the server. Any abnormalities is happened in the server, this will take. Okay, so maskable interrupts also studied. And see, in the maskable interrupts there is a one cycle. Just I have to made you, this is not need, just I have to show you how the maskable interrupts is happened. So here today I will go through with maskable interrupts. After that I will move to uh, one of the architecture 8259 we will study in detail. Okay, so from the last lecture, again this one topic is left out, that is maskable interrupt. Dear student, previously I covered non-maskable interrupt. Maskable ये मतलब ये होता है कि like enable or disable. Maskable means disable. Okay, so we have to cover with the interrupts that is maskable. It means we are disabled, but in this, in the maskable interrupts we may disable also user. That's what maskable interrupt is higher priority over than the non-maskable interrupts. So here in this maskable interrupts, that is the microprocessor 8086 whatever we are going to use it. 8086 में हमें maskable लाइन नॉन maskable यूज करते हैं. So non maskable की ये होता है कि it's a disable and non-disable, like that. Interrupt and non-maskable interrupts. So in that, the signal level triggered and can be masked with the registering power. That is restrictions with the interrupt flags. So total 9 flags we are studied, and उसमें out of 9 flags, 5 flags, 3 flags we have to study interrupt flags. What are interrupt flags? RST5, RST6, and RST7. Yes, so in the pin diagram of 8086, that time you saw that. So totally 3 main interrupt flags are there. So those are controlled by maskable interrupts. And in this maskable interrupts, the processor responds to an interrupt signal for the instruction pointer automatically. Along with that, the processor 8086 also provides in this 80-pin INTR, and in that the signal is passed for the processor to decide actually which type of interrupt it is. Which type of interrupt, that is decided by the maskable interrupts. And the interrupt signal is a triggered and can be masked resetting with the interrupt flags. This is the third point. So one more point, that is the interrupt flags is set, processor is to ready to respond. So in the maskable interrupt, the interrupt flag is going to be set whenever the processor is ready to respond. The processor is ready to respond, and the interrupt in the interrupt flags is reset. The processor will not serve any interrupt. So any kind of problems or any kind of abnormalities is not going to be served. अभी interrupt के अंदर, maskable interrupt के अंदर कुछ तो interrupt is not working in the fine manner and it is not going to be solved. उसी time पे we have to reset it, and we have to serve by appearing in the same pin of the 8086 maskable interrupts. And one more point, once the processor responds to an interrupt signal, then the interrupt flag is automatically reset. That is also one of the main feature of this interrupts, maskable interrupts. And if the it wants to processor to buffer respond to any type of interrupt signal, the interrupt flag should again be set. So this is also a very important point. And again, it suppose an external signal interrupts the processor and the pin lock, the pin lock, one lock you are going to use it, right? In the pin configuration of 8086. That is also goes to low at the trailing edge of the first algebraic unit to false that it appears after the interrupt signal preventing in the used for bus for any other purposes. Okay. And one more, that lock is used for to remove low level of start and next machine cycles. So if the one interrupt is going to connected with other interrupt, that time it is removes the low low signal transfer till the start of the next machine cycle. So up to start of the next machine cycle, it is going to be carried. That is log. So with this trailing of edge, the log and interrupt acknowledgement, INTA means interrupt acknowledgement goes low and remains low for 2 clock states before returning back to the high state. So here in this, I have to made one uh, timing cycle. I have to made one timing cycle signals, that is T1 to T4 first cycle, T1 to T4 first cycle, and again T1 to T4 second cycle. So you have to break at the midpoint between T4 and T1. So it becomes, this is the one cycle and this is the second cycle. So in the first cycle, how the maskable interrupts are working. So in the maskable interrupts, you have to give input to a clock. That clock is this way. So enter this one cycle up to T4, and here next cycle T1 to T4 and T1 to T4. One cycle plus one cycle. Totally 2 cycles time span I have to mention here. In that ALE, there is one. So in the ALE, you have to observe that during the maskable interrupts, the first cycle quarter part, only the quarter part, it means that only the T1 part, T1 time of part, it is going to be enabled. After that, in T2, T3, T4, it is going to be disabled. Okay. Enable in the sense what? It is going to be high, that AL is going to be high only in the quarter part, T1 time of part, and after that it is going to be slow down and it is going to be zero in the T2, T3, T4. Same way in the next half cycle, and it is continuing further subsequently remaining cycles. Okay. And actually our main aim is to control the clock. This clock at beginning, this clock at beginning, it is high because once we applied a clock, it is going to be high, and that is going to be reduced whenever the ALE signal is disabled. The ALE signal is disabled, automatically the clock is also going to be disabled over here. After that, in the next cycle, automatically whenever ALE goes to high, but the clock is goes to low, and it is reverse in the second cycle totally. At the beginning high in the quarter part, and remaining three-fourth part is going to be disabled. But in the next cycle, you are going to be observed, that is clock is at the beginning. In the next cycle, clock is at the beginning, it is disabled, and later on it is going to be enabled. That is reverse of first cycle, because the clock is going to be changed from high to low and low to high. Same way, come to this point, that is interrupt acknowledgement. So in this interrupt acknowledgement, it is same as like of clock at the beginning. It is also high, and after two cycles, T2 and T3, this become a low, and that T4 again it goes to high, and it is same remains as it is in the cycle number 2, and subsequently same on it is going to be handled. So entire this ALE clock and interrupt acknowledgement along with the clock. So what it will happen? The data transfer or the information from AD0 to AD7, that floating, which can be interrupt type, that interrupt type is occurred at this point in the number of cycles second. So this one I'm just showing one of the theoretical, but practically we will think that the interrupt acknowledgement is going to be affected in the second cycle, not in the first cycle as per maskable interrupts. So this main intention we have to study this. Okay. So that is interrupt acknowledgement sequence of 8086. Here that should be happened in the second cycle. So this is the in maskable interrupts. And here for the non-maskable also we have to taught a very short. Non-maskable means it is a processor 8086 has a non-maskable interrupt input pin, that is NMI, that has highest priority. Non-maskable is highest priority among the external inputs. So here in the highest priority, we have to use the trap for the single step type, and we have to use the NMI activated for the positive transition. And here is an internal interrupts having the highest priority for the NMI amongst all the interrupts except divided by 0. So totally you have to study it on that day 5 interrupts except divided by 0. This is going to be handled, that non-maskable interrupts. So this is about just a brief idea for maskable and non-maskable. So just 1 or 2 minutes again I will repeat this story for the maskable and non-maskable. अभी maskable में and non-maskable में, which is disable and enable, and non-maskable is the highest priority compared to maskable interrupts. So these two, अभी ये दोनों टाइप मास्केबल एंड नॉन मास्केबल हम एक यूज करते हैं अंडर द हार्डवेयर इंटरप्ट्स. ये दोनों भी very short, we have to cover very short things, not big things. We have to cover whatever the abnormalities or the difficulties or the any other kind of problem is facing during the execution of program. In those type of problems, difficulties or abnormalities, we are going to handle by using maskable and non-maskable, totally the hardware interrupts. But we are not 100% to resolve the problems by using maskable and non-maskable. What I have to say, we are not resolved 100%. For that, again, we have to do some alternative arrangements. See the students, अभी हम वो ये 100% का सोल्यूशन नहीं मिल रहा है, 100% का सोल्यूशन नहीं मिल रहा है by using maskable and non-maskable. उसके लिए because of lot of drawbacks, because of limitations of this maskable and non-maskable interrupts, we are going, हम ये extra interrupts use करते हैं, उसको हम ये बोलते हैं कि programmable interrupt controller 8259 microprocessor chip. So due to overcome of that hardware interrupts like maskable and non-maskable, to overcome of those, to limitations of those, to drawbacks of those, we are going to use 8259 interrupt control microprocessor chip. Okay, very nice. Up to now, what I covered, maskable and non-maskable, uh, they may ask questions only MCQ, multiple choice questions, but in 8259, you have to clearly understood very important as per exam point of view. So अभी इतना सारा limitations था तो हम 8259 microprocessor use करके we have to get the solution of minimum 97-98% we have to get the solutions from 8259. So 8259 also some drawbacks are there. I will explain during this topic. But majority of the abnormality conditions or problems or difficulties we have to resolved by 8259. Maximum majority, maximum percentage. Up to 97-98% we have to verify it and we have to execute the programmer. So for that अभी 8259 है ना, इसमें हम तीन चीजें स्टडी करना बहुत जरूर है. 8259 it is like also a 825 8085 8086 microprocessor only, and in the minimum mode and maximum mode we have studied 8282 microprocessor chip, 8284 microprocessor chip, 8286 microprocessor chip, and in the maximum mode 8288 microprocessor. 4 microprocessor chips we studied in the minimum mode and maximum mode, those in the unit number 4, right? Same way, in the interrupt, we have studied one more microprocessor chip, that is 8259. ये 8259 के अंदर तीन चीजें हम पढ़ाई करना बहुत जरूरी है. First thing, what is the applications of 8259, why it is used, first thing. Second thing, architecture or the block diagram of 8259 study करना बहुत जरूरी है. पहला चीज ये है application study करना. Second चीज ये है block diagram or we have to say architecture. And the third thing ये होता है functionality or working or operation of 8259. So तीन चीजें हम पढ़ाई करना बहुत जरूरी है. कौन सा है वो तीन चीजें? पहला applications, second architecture or block diagram, and third operations or working functionality. So now I will carry with this 8259 architecture. Here मैंने पूरा clear dictate notes भी किया है, सब चीज इधर है. So this is the architecture block diagram. Here block diagram I have to mention 8259, or we have to say architecture also, no problem, both are same here. And सारे इसका explanation, data bus buffer एक block, read and write logic block, cascade buffer, compensator, comparator, and in service register, priority resolver. This is the main resolver to solve 97 to 98%, and internal request register. So these internal request registers are not to IR7, and interrupt mask register, interrupt bus is there. So here interrupt acknowledgement and interrupts, that is controlled by logic controller. These blocks clearly I have to use it. Architecture of 80859, that is interrupt request register, priority, in service register, interrupt mask register, interrupt control logic, data bus buffer, and read and write control, cascade buffer, controls. These are the pins: CS, read, that is code segment, read, write, data lines D0 to D7, cascades, that is 0 to 3, total 3 cascades are there, and stack pointer, enable, interrupts, that is interrupts, register 0 to interrupt register 07, that is interrupts acknowledgement, and this is the pin diagram, interrupt sequence. These things entire I have to make prepared, well prepared for the notes. So dear all students, now I will explain, पूरा हम अभी explain सुनाएंगे, that is applications, architecture, and working functionality. So I have to keep it up. Okay. So this is the diagram or block diagram. So this one I am going to explain by using some more short notes I have to prepare for this. Okay. It's fine. Okay, dear student, just it's fine. Just you have to compare that soft copy to my written notes. Is it both are same? Just you have to check it out. Okay, I think both it is same. Only here I am using internal bus, but this internal bus he didn't mention. There is a one missing, that is internal bus. Remaining all blocks are same. So that is data bus buffer. So data bus buffer is there from D0 to D7, and read and write logic. That read and write logic is there with A0, read, write, and that control signal. So cascade buffer comparator is there. Here also cascade buffer comparator is also there. That is 0 to 2 means 3 cascade buffer comparator. And here a stack pointer enable is there. Here also stack pointer enable. Next you have to check interrupt acknowledgement and interrupts. Here are there with the logic control. So next in service register, priority resolver, and interrupt request register. So in service, priority and interrupt request registers are there. So here seven interrupt registers are used. So here also 7 interrupt registers are used. Interrupt mask register. This is interrupt mask register. Sometimes we have to say it is a block diagram, or sometimes we have to say it's architecture, programmable interrupt control architecture. Okay. So here at the first applications are, we have to say features. What are the application? The main application is whatever overcome of maskable and non-maskable interrupts are there, limitations of maskable and non-maskable, it is going to be resolved in the 8259 microprocessor chip. Okay, that is the main application. And the main features, that is 8259 programmable interrupt controller has a main 8 interrupt pins are there. Mainly 8 interrupt pins are there, and it can handle 8 interrupts inputs because of 8 interrupt pins. And next one, don't worry students, this short printed notes I'll send you after this lecture to the WhatsApp group. You have these notes after this lecture, don't worry. And just you have to observe now. The second point, the priority of interrupts in 8059 can be programmed with the priority of interrupts is decided by the difficult of operating modes. Different of operating modes. So this E8259, except the maskable and non-maskable operating mode, we have to use some different kind of operating mode to resolve by the 8259 microprocessor. And here in the third point, in the 8259 can handle 8-bit interrupt inputs as the first point, but cascading multiple 8259 can be handled can be handled with the 64 interrupts because of 8 into 4. That is totally 64 interrupt spins are going to be resolved in the 8259. Next, in the fourth point, it can allows individual masking of each generated interrupt using the interrupt mask register. Okay, it can generate each interrupt using the interrupt mask register, and also it is programmed in a way that it can handle either edge triggered or level triggered interrupt request at a time. So both edge triggered and level triggered, both it is handled at a time. That's what it is most popular for resolving the interrupt problems. And in the sixth point, it is also flexible for multiple interrupts whenever is going to be generated. That is holds with the status of interrupts that are masked with service and pending. So finally, it is going to be give the good service to the interrupts. And in the 8259, it reduces the software and real-time overhead generated due to the handling of multi-level interrupts. So the 8259 is a more capacity, more capable to do the to resolve the overhead problems by using 8259. So this is the applications. Actually, I have to mention feature. So that feature is going to be explained with the applications, or you have to mention applications of 8259. No problem. Okay. So this is entire application. Next, the point I'll come to architecture of 8259. So this is the architecture. So from this architecture, mainly 8 blocks, mainly 8 blocks. Okay, so here internal bus is there. Internal bus he is mentioned here only. Yes, that is also not missing. Everything is, I think everything is exactly Xerox copy of what I have to use and whatever it is there in the textbook. Okay, so here mainly we have to explain 8 main blocks. What are 8 main blocks? Data bus buffer, read and write logic, cascade buffer, and comparator, in service register, 1, 2, 3, it is 4, and fifth is priority resolver, sixth is interrupt request register, and the seventh is interrupt mask register, and eighth one is control logic. So this is entire architecture of 8259 programmable interrupt chip or microprocessor. 8259 chip. Okay. So these blocks, this is a architecture. Now what we will do? We will explain one by one in detail. So here the figure shows the architectural representation of 8259 programmable interrupt control. Programmable interrupt control. We have to see PIC. So here in this, there are 8 data bus lines are there. That is D0 to D7. So it has an 8-bit data bus. 8-bit data bus, as we have already discussed in 8259, never services the interrupt is simply towards the interrupt to the microprocessor. Okay, anything related. And in this, the architecture has a different units community functions. That is, we have to different community means all these 8 blocks along with internal bus, including internal bus, total 9 blocks we are going to be explained here. So in that, I have to take first one, data bus buffer. This block we are going to be explain what are the things in this block. So already you studied bus system, architecture of system bus you studied. So in that architecture of system bus, there are 3 types: data bus, control bus, and one more is address bus. 3 buses you have to study: data bus, control bus, and address bus. So that time I given you one of the good example, real world example, that is bus, right? Your state transfer, ST, you say ST. So that example also I will give how it will work out, these 3 types of buses. So in the first block, that is data buffer block. So in the okay, so in the 8259 has a tri-stated bidirectional 8-bit data bus. Why it is bidirectional? Transmitter as well as receiver of data going to be happen with the D0 to D7, and that interfaces with the normal bus of the microprocessor of the processor, that 8085 microprocessor sends and receives control status. Whatever in the 8085 we are using the data bus, same it is working functionality of D0 to D7, that is data bus buffer. And in the next block, that is read and write logic. What it will do? Read and write logic. Something is going to be read it and something is going to be written it. So that is read, and RD is for read, WR is for write. So that is responsible for controlling the internal read write operations of the system, and it can hold the initialization command word register and operation command word register. So that is read purpose and write purpose. Inside the various control formats exists, in that it should be needed for the device operations. So that is for read and write logic in the second block. So here in the read and write, and also the A0 and the CS means control signals are the pins of the associated with this init, and basically these pins are used for that A0 and control signals. These are used for by the processor for read and write operations. So either it is going to be high means only read, and low means both read and write operations is going to be happened in the read and write logic of 8259. And next we will come to the control logic. This one we will come to the control logic. In the control logic, whatever the interrupt acknowledgement and the interrupts means abnormalities, whatever we are going to be sent, and there is a handshaking priorities happen. Again, it will send to the interrupt acknowledgement to the control logic. That unit has to be set heart of the architecture. The control logic is like a heart of the architecture of 8259, and it controls overall operations of the system by sending the interrupt signal, by sending this interrupt signal to the processor whenever an interrupt request is generated. So once the request is generated from the interrupts, that is going to be controlled by the logic. So in that interrupt acknowledgement, here in this part, the signal by the processor when the microprocessor demands. Yes, please, any questions? Okay. So the microprocessor demands for the address of the interrupt service routine to resend back the acknowledgement. It is to find the address of interrupt service routine, and by the help of control logic, that is going to be recover the signal, and it is responsible for sending the address of the desired interrupt service routine, whatever it will comes from the interrupt signal. Again, it is resolved to the and send it back to the control logic. So that is the main functionality of control logic. So next block, data bus buffer is over, read write is over, control logic is over. Next, I will come to the point, that is interrupt request register. This one, IRR, interrupt request register, fourth block. So in this interrupt request register, we have to use total 8 interrupt request lines. What are those 8 interrupt request lines? IR0, IR1, IR2, IR3, and to are 7. Totally 0 to 7 means 8 interrupt request routines we are register we are going to be used in the interrupt request. So actually we have to send the request to going to resolve the signals by the interrupt request registers. Okay. So in this interrupt request register, uh, it is requests are generated by the peripheral devices. That is, when the 8259 has an 8 interrupt request, totally IR0 to IR7, 8 interrupt requests, so that the unit can store 8 interrupt requests that are requesting to the service from the processor at a time, to the processor at a time. That is throughout the interrupt request routine. Okay. So after that, we will come to the priority resolver. Once we are send the request through the control logic to the interrupt and get the interrupt acknowledgement to recover the signals to the control logic. After that, again we have to send the interrupt request. We have to send the interrupt request. Once we will send the interrupt request, the priority is going to be given to which one is going to be handled first. That is done by priority resolver. That is done by priority resolver. So in the priority resolver, you have to get the solutions, and that is after the priority resolver, you are going to be given to next block, that is in service registers. To happen the service means, to happen the service, you are going to be resolved it. So in the incoming request has a greater priority than the one which is being in the current execution, than that of respective interrupts requests, and that is again sent to the microprocessor chip to going to be handled. After that, in the microprocessor chips, in service is going on, that extraction is going on for the priority signals. Sorry. So here in the in service register, the units of is indicating operation performed in it, and the register in it stores in the interrupts which are currently being executed by the processor. So that service, in that service, actually it is going to be executed as usual normal conditions. So here buffer to read, read to control logic to register, request registers to priority, up to priority to, it will comes to the normal stage to going to be resolved, going to be execute the program, going to be execute the program. That's what we have to mention here. This register unit stores the interrupts which are currently being executed by the processor. That is a resolved point executed by the processor in this in service registers. So in the priority wise, the priority resolver sets each bit of ISR interrupt service routine, and after getting the interrupt word command by the processor, as the processor holds the ability to directly read the status of in the service registers. Okay. So now whatever I covered, data buffer I covered, read write I covered, control logic I covered, and these three interrupt request to register, priority resolver, and in service. Next, I will go to interrupt mask register. This one. So what is this functionality in the 8259? The main functionality is, again we have to use the word mask. Mask is means what? Enable and disable. It is a enable and disable. So here interrupt mask register. So in this, the register unit holds the masking bit of those interrupts which are to be masked. Whatever the masked are there means interrupts, maskable interrupts. That is the operation command word operation command word OCW. I will explain you in later it will comes. ICW and OCW2 are there. That is operation command word that processor sends the required information and programs the interrupt mask is register. Okay. So this is interrupt mask register. So next and the last block, cascade buffer comparator. So in the cascade buffer comparator, we have to use three signals CAS0 to CA1. Sorry, CA2. CAS02, CAS2, totally 0, 1, 2, 3 cascade signals we have to use. So in this, the multiple cascading of 8259, the number of interrupts handled by 8259 can be extended up to 64. As I already mentioned in the application, up to 64 bits. The init allows, this block allows the comparison of IDs, allows the comparison of IDs of different 8259 cascade together signals. So different, every signal is generated that is along with one IDs, and it is going to be compared and given request to the control logic. So only this is going to be I connected to control logic. In that it is going to be decided. So totally 3 control signals are there. So again, this is the same explanations I have to given here, entire this one. So this one I will send you because it is one of the big pages. Only I have to cut and transfer to you students. So this is the main explanation of 8259. So dear students, as per this architecture, I have to given you the notes, entire clear notes. So yeah, just a second. See, as per this architecture, all of you please observe the first point architecture, interrupt request routine. So this interrupt request routine, I explained in service register. So in service register, I explained, and priority resolver. So priority resolver, I explained. Interrupt mask register. So interrupt mask register, I explained, and interrupt control logic. So this is the interrupt control logic I explained, and data bus buffer. This is the data bus buffer. So next I explained in my notes, read write control logic. So this is the read and write control logic, and cascade buffer comparator, cascade buffer comparator. So all the blocks I have to explain. Along with that, whatever these pins are there, that pins also I have to explain. CS I explained here, CS is there, and RD, WR both are here. I explained. D07 to D0 to D07 I explained here, and cascade 02, cascade 2, 3 signals whatever is there, 0, 1, 2 I explained, and SPN enable, stack pointer and enable also I have to explain here. Next, then interrupt INT pin also I have to explain, and that interrupt request routine so register, that IR not to 0 to IR7. All these I explained in my notes. And in the 7th point, interrupt acknowledgement also is there. That interrupt acknowledgement is also explained. So this is the pin diagram. This is the pin diagram of 8259. 8259. Either you say pin diagram of this or block diagram or architecture of 8259. So dear students, I think I covered 8259. So I'll give you a 5-minute time, dear all students. If you have to read it out, you have to read it out. And if any doubts, please ask me about this 8259, because 8259 is very, very important as per your exam point of view. That's what I will give more place to this. So please, you have a 5-minute time to discuss on this. So this one, I'll send you, all of you, I'll send you now this one, this printed notes for the 8259. Just a minute. Okay. That's fine. Here. 8259 PIC. PIC in the sense what? Programmable interrupt control. Okay. So now all of you come to microprocessor group. Come to microprocessor group, and in that I will add. So in that okay, dear students, all of you come to microprocessor group and you have to check it out. I sent that printed notes. So these printed notes as well as my notes, handwritten notes, please you compare, you have to study. So any doubts, take a time, do the study. If you are not understand, अभी किसी को तो भी इवन एक लाइन भी समझ में नहीं आए तो भी मुझे पूछ लीजिए. अगर आपको ग्रुप के अंदर नहीं पूछ सकता है तो मुझे टेक्स्ट कर दीजिए व्हाट्सएप पे. आई विल गिव यू द सॉल्यूशंस. ओके, टेक यू हैव 5 to 10 minutes and read it very slowly. Only bit things we have to cover, and we have to cover it. We have to study it perfectly. That is my intention. Okay, dear student, go through these notes and my printed. Both the notes we have to compare and study. If any non-understanding things are there, please let me know. Just for 5 minutes. Don't give attendance. Still we have please make please make me who are there. Better I will mute you. Okay, dear all students, take your 5 minute time and read well. Again, I will continue the lecture up to 11:30. See, 47 rule number division B 47. Two numbers are available here. Akush Patil, Saurabh. Why you have to mention both of you single number? Please, am I audible? Saurabh Gulamka and Akush Patil. So if you have to do, then I will put it both of you absent. Tell me who is real B47. Okay, if not, then I'll made you both of you absent. Please listen my voice.
Yes, sir.
Yeah, your roll number is?
47.
Then two numbers are available. Okay, one is, yeah, your name is?
Saurabh Gulamkar.
So Gulamkar. Who is Akush Patil? You check it out. His number also B47. Okay, Saurabh Gulamkar is B47. I will make you present. Akush
Yes.
Patil. Akush Patil ji. Otherwise, I will put it absent for you. I want to know who you are. Okay, fine. You are absent. Yes, fine. So please, dear all students, you have to sign in by using your division and rule number. So someone are I'm getting two numbers with different names. Two same rule number with different names. So you have to check it out. All of you with your rule number, any others one is going to be joined. If this is the case, I request you to please avoid it. Otherwise, if double numbers are comes, we have to make it zero. So you have to make it absent. So I need to say this, please all of you have to check along with your rule number, any other rule numbers are going to be login. Check it please all of you. Okay, next lecture onwards, this is not going to be happen. It is my request, please all of you strictly follow the rules and regulations of lecture. And other than our student, other than our very student, no one is allowed, strictly forbidden. Please, you don't allow them to join any other student also. In such case, anything discrepancies happened, uh, that rule number students are going to be responsible for that. Please, all of you, obey the rules and regulations of lecture. It is my request. I will repeat it twice. Please, you have to respond and act accordingly. Okay? As fine. Yes, dear students, whatever I covered today, is there anything, uh, questions, please let me know. I'm waiting your questions. Any text? So I didn't got any text also. If you, any questions is there in your mind, please text me. If you are not able to ask orally, okay, then it's well and good. Okay, please, still 10-15 minutes is there. you go and study these notes today, whatever I covered. So, so I think all of you are uh, feel good for the today's lecture as per my speed. Please personally message me how you feel at the today's lecture. Is it speed or on an average or slow? Whatever you feel, you have to present me through the text. Okay? Yes, fine. Uh, if no any questions, so shall I move to next topic? Yes, fine. This is the case as per my notes. So next, again, just a short. Please, all of you listen here. Dear all students, come to my screen. All of you come to my screen. So again, next topic as per 8259. There is an interrupt sequence in 8086. How it is going to be a map that 8086 with 8259 programmable interrupt control chip. Okay. So in this, because along with 8086, we are going to use 8259 microprocessor chip. Okay. So it means that we are going to connect with each other, 8259 and 8086, because whatever the overcome of the limitations of 8086 are there, that is we are going to resolve by using 8259 microprocessor chip. So that extra 8259 microprocessor chip we are going to connect with 8086. That is the 3 to 4 points I have to explain here. That interrupt sequence in the 8086 to 8259 system, that is described as follows. So one or more interrupt register lines or interrupt request lines are raised high that to set the corresponding interrupt register interrupt request register bits. Based on that interrupt request with interrupt request register, we are going to be mapped while connecting between 8086 and 808259. That first point. And in second point, whatever we are going to resolve the problems of 8 to problems from the 8259, that priority and sends the interrupt signals to the CPU. That is CPU in the sense what here? That is 8086. And the CPU acknowledges with the interrupt acknowledgement, INTA, interrupt acknowledgement pulse. And the receiving signals from the 8259 with the interrupt acknowledgement to the CPU to the 8086, the highest priority of interrupt service routine bit is set to, and a corresponding interrupt request register bit is reset. So the 8259 does not drive data, or it does not move or does not transfer data, but during this period of interrupt service routine. So in the fifth point, the 8086 will initiate, because we are going to be connected 8259 to the 8086 microprocessor, that will initiate a second interrupt acknowledgement pulse during this period of 8259 programmable interrupt chip or programmable interrupt control. It can release 8-bit, because as of already we know, it is works on the 8-bit capacity. So the 8-bit pointer on the total bus from where it is read by the central processing unit in the 8086 microprocessor it is. And in the last point, that complete Please, I request you to, if you don't have any questions, make mute. Who is that? K11, Shayhali Linge. Shayhali Linge, please you approach me after this lecture. Shayhali Linge, please you approach me after the lecture. You are going to be disturbance the lecture. Please you avoid such things. Okay, fine. Anyhow, they are our students. Yeah. Okay. So these are the things, dear students. While we are going to be connected 8086 with 8259 programmable interrupt control chip. Okay. So I think I will not much cover. And later on, we will study the command words. Later on, we will study the command words of 8259. That ICW. Also, we studied OCW. Also, we have to study it. These are the different data lines. Again, we will carry it in the further next class. Okay. So totally IC4. These are four ICWs are there. Word bits are there. And next we will study the operational command words OCW. So like this, we have to cover one by one in the next lecture. So dear all students, still you have 15 minutes time. So please don't waste the time. What you will do, you have to go through my notes and whatever I covered today. Today's topic is very, very important for your exam point of view. Please all of you keep in your mind. And this one, you have to do study very well. Till 15 minutes, you have to utilize, go through these notes, scan these notes thoroughly. If any doubts, any not understanding points are there, let me know, please. Tomorrow onwards, means next lecture onwards, so we will study command words of 8259. Okay? Okay, fine. So still you have 15-minute time, please utilize. Go through these notes, scan these notes very well, and let me know anything else.